Hello and welcome to Code Smash. In the pointers tutorial 1 we discussed about memory and pointers, reference operator and dereference operator and the declaration of a pointer type variable. Today we are going to talk about void type pointers, pointers and arrays and passing pointers as arguments to functions. Now let's get started with what are void type pointers. Now we knew that if we execute this kind of instruction that int static p, we know that variable p must point to a variable which would also be an integer type. But with void type pointers, we don't have to worry about to which type of variable this pointer p is pointing to. So the name suggests that we don't care about which type of variable it's pointing to. So it's very easy concept. It's all about void type pointers. So our next topic is pointers and arrays. We've discussed about arrays. We know that they have this kind of structure in the memory, with this being 0th location. This is 1, 2nd, 3rd, 4th, 5th, so on. So when we declare an array like this, what happens in the memory that these 5 cells of memory are allocated to this array X, and the size of this cell depends on the type of X. I mean, as this is an integer type variable, so this cell would have a size of 2 bytes. Also this one. Each of these cells would have a size of 2 bytes. But if we would have done such thing, now this would take only 1 byte per cell. So I hope you've grabbed the concept. So here we're going to declare a pointer p, and without indexing an array, or in simple words, by writing p is equal to x, what we are doing that we are getting the address of the starting location of this array x and giving it to variable p. Okay, so the starting address of this is 0 and this is given to p if we use the array without indexes. But if you have to point to a certain location, let's say this location 2, it must have some memory address, such as, let's suppose that it has memory address of 0xff. So if we were to point to this memory cell of the array, we would have to write something like this. Now p would point to this cell, not to the starting address of the X array. So when we have to move, initially we point our pointer p was pointed to this memory cell. But let's say we have to sort this array in ascending order or whatever. We have to access all of these cells one by one. So how to get to this cell from this or cell or so on? We do that by incrementing this pointer p by executing this command. What happens in the background is that our pointer's address move from this cell to this cell. and the next time to this cell, to this cell. Hope you understand. But there is one important thing to be discussed here, and that is that the increment actually done at the background depends upon the size of the type of this array. As I've mentioned before, that an integer costs 2 bytes. Okay, so what happens that if we had, for example, it's going to be a little messier, but if you get it, if this memory location was 100, the next would be 102. So if the pointer value was 100 and we did p++, it would have given us 102, and next time it would have given us 104. So what if this array was declared not as int x but as character x5? Now this was for int, this is for character, just to show you the difference. P was originally pointed to 100th location, and when we executed this command p++, what happened that P was assigned a value of 101. Now see the difference. It was changed from 100 to 102 because the size of the int type variable is 2 bytes minimum. So here a character type takes only 1 byte for a memory cell. This is 1 byte, this is 1 byte. But in the integer case, this is 2, this is 2. Similarly, a double takes 8 bytes per cell. This is for double. And similarly, a float takes 4 bytes per cell. So I hope you have understood what I try to make you understand. So this was all about pointers and arrays. Our next thing, which was passing pointers as arguments to functions. Now we are going to discuss it with an example. It's an interesting one. I'm skipping to the main. So we have defined a function here. You can see that it has arguments of type pointers, and these pointers are being given values and being updated in this function. So what's happening here? We have defined two variables x and y. We have given them values. X is equal to 40 and y is equal to 10. We have called the temp function, and we have passed to this function the addresses of x and y, which in other words you can say are the pointers to x and y. Now what happens? Our program flow comes from there to here. What happens here is that the steric sign, as we know, is the dereference operator. It means the value pointed by x. So the value pointed by x is 40. And here, in other words, this means that 40 plus 100. It would give us 140. And the value pointed by y was 10. So in other words, it would mean 10 plus 100, it would give us 110. So when we would see out x and y, at the output we would get x 140 and y 110. So we have seen that we can also use pointers as parameters to be passed to the function. So this was all about pointers. Next time we're going to discuss some more stuff, and this is all. Thanks.